Welcome back to another video in our Android starter course. So in this video, we're going to basically be taking some of the knowledge that we've learned so far and then applying it in a really simple project where we're building a game. And it's going to be a tic-tac-toe game. So if I click on these buttons, you can see I'm using a button composable to represent the tiles of the tic-tac-toe game. But if I click on one, you see X and then O, and then it's switching back between whose turn it is every single time. And eventually, if I get to a point where I have 3 in a row, well, then the game updates us to tell us that X has now won the game. And all of the 3 in the row that caused the victory for X, it changes colors on the buttons to easily visually highlight who won and why they won. There's also a reset button here at the bottom to flip the game back to the initial state so that we can play again after the game's over. So this is a pretty easy, pretty simple app, and we're basically going to be using a lot of the skills and a lot of the knowledge that we've learned up to this point in this class. And this video is just going to be showing how to do that. So let's go ahead and get started with that. Let's make a new project. Select empty activity. I'm just going to call this tic-tac-toe. For minimum SDK, I'm just going to leave it at 30 because that's going to work with all of my virtual devices that I already have set up. I'm going to click finish on that. Now in here, in my main activity, the first thing I'm going to do is delete all of this auto-generated code that we're not going to be using. And then over in the project window, I'm going to go ahead and make all of the files that we're going to need for this project. So I'm going to make one called tic-tac-toe state, and this is going to do exactly what it sounds like, and that's going to be, it's going to track our state. That one's going to be a data class. I'm going to make another one in here, and we're going to call that, it's also going to be a Kotlin class or file. We're going to call that one the tic-tac-toe screen. And this one's actually going to be a file. And then I'm going to make another one in here for the view model. So Kotlin class or file. This one I'm going to leave on class, and we're going to call it tic-tac-toe view model. So now let's start with the state, because we kind of need to define what this is going to look like before we can do anything else. So in this state, what we're going to need to do is inside of the constructor, we're going to pass it all of the information that we need to track for our tic-tac-toe app. So if you look back at this phone here, you've got all of your buttons, and on every button, you've got some text displayed. Either it's a dash if it's blank, or it's an X or an O. And then also we have whose turn it is and who won. So if I click reset on that, you can see it's X's turn, so I click X, and then now it's O's turn, so I click and it's X's turn again because O just went. Now it's O's turn again. So we're tracking all the data on each button. We're also tracking whose turn it is, and we're also tracking who wins so that we can display that to the user. So to do that, in here, I'm going to have I'm going to have an array first of all. That's just going to be button values. And this is going to be an array of strings, which is equal to an array of, and in here, all I'm going to do is give it 9 of these dashes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my button values array. And then after that, I'm going to need a value to track whose turn it is. So basically, I only need to track one of these. So because there's only 2 players in this game, so if it's X's turn, then we're going to write X. And if it's O's turn, then this value is going to be false, because if it's not X's turn, it has to be O's turn because they're the only other player in the game. So val is X turn is a Boolean, and that's going to be equal to true by default. In our game, we're always going to start with X going first. And then val, we're going to have a variable for the victor, so whoever wins this game. And this is going to be a null string, which is going to be, well, this is going to be a nullable string that we're going to set equal to null initially. And at the end of the game, we're going to set this to either X or O. But until then, we'll leave it as null. Now, there's one more thing that we're going to track in our state. If you look back at our game, you could see whenever somebody wins, we're changing all of the colors of the buttons that won the game. So the 3 in a row, we need to change to a different color to kind of highlight that they won. So I'm going to have one more array in here, and this one I'm just going to call val button winners. This is going to be an array of booleans, which is initially going to be equal to, whoops, that needs to not be plural, an array of Boolean data types. And this is going to be an array of, and we're just going to write false. And then same thing as above, we're going to have 9 of these because we have 9 buttons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is going to be everything that we need in our tic-tac-toe state. Well, actually, I have a couple errors up here, and that's because I didn't put commas after these. So because these are obviously within the constructor, these parentheses here, you need commas at the end of every line if there's a line coming after it. And then also you'll notice you have a warning here. So if you hover over that, basically it's saying, hey, you have this array and it's inside a data class, so we recommend that you override the equals or the hash code so that you can use that. You can click on that if you want. That'll get rid of your errors. But for our purposes, we're not going to be using the equals or the hash code, so we don't really need that. But I'll just leave it there so that warning goes away. Now that we have our tic-tac-toe state in order, let's go into our tic-tac-toe view model and see what's going on in there. So we need to have this inherit from our view model from Android X lifecycle. So go ahead and do that. And then inside of here, the first thing we need is a reference to our state. So private val underscore state equals mutable state of, and this is going to be tic-tac-toe state, and then pass it that empty constructor. Next, we're going to have a public value, and we're going to call this state with no underscore, which is going to be of type state. Go ahead and import that. Compose runtime is the one that we want, and then tic-tac-toe state, and this is going to be equal to underscore state. And just to reiterate, the reason why we have 2 state variables here, so this first one, underscore state, that is going to be our private variable for use within the view model. And then this second one, state, that one is going to be set based on what the private one is set to. And what this does is it's going to allow our screen to read our public state, but not be able to modify our actual private state that we're using within the view model. Because we don't want our composables to be able to change our state. We just want them to be able to pass data back. And then the functions that we run within the view model itself is going to be what changes our internal state. We'll start with the easiest function in here, and that's going to be our reset function. So fun reset board, and this takes no parameters and returns nothing, and all that you need to do is state.value equals tic-tac-toe state, and again leave that empty just like we have up here, and that is going to basically give us a new state of tic-tac-toe, a new default state, which is going to have all blanks and then all falses for the color, with it set to X's turn with no victor in there. So that is really all you need to reset that. The next thing that we need to do inside of this is whenever a user clicks a button, so let me just bring up this phone here. Whenever a user clicks a button, we need to change that to either an X or an O, depending on whose turn it is. So to do that in here, I'm going to make a new function. We're going to call it fun set button, and this will take in an integer, which is going to be the ID of the button. And let me just remind you before we go on that if our array is 9 elements long, we're going to start counting at 0. So our first button, this guy right here, is actually going to be index 0, and then it's going to go 1, 2, 3, 4, 5, 6, 7, 8. So we have buttons 0 through 8 for a total of 9 buttons. But when you're working with an array, it's very important to remember that you start with 0 and not with 1. So let's go back to Android Studio now. And in here, inside of this set button function, basically what we can do is we can make a copy of our button data from our state. So I can say val buttons equals state.value.buttonValues.copy of, and that's going to give us a copy that we can then modify and then copy back into our state after we've modified it. And because we know what button was pressed, and that's whatever button this ID matches here, all we really need to do is put an if statement in here, and we could say if state.value.isXturn, then what we need to do is say buttons at the index of our ID that we passed in is equal to x, else the buttons at that same ID that we passed in is going to be equal to O. And then after we're done with that, we can do state.value equals state.value.copy. And again, this .copy function is a function that comes with data classes. So because our tic-tac-toe state is in fact a data class and not just a regular class, what we can do is in our view model, when we set it, we're going to set it back equal to itself with the .copy and then change any elements inside of that we want to change based on the parameters that we passed in. So here, what we want to do is say button values equals, and this is going to be equal to our new buttons array that we made. And then after that, there's one more thing, because you remember in our state, we're tracking whose turn it is. So after X takes their turn, we need to toggle that so that now it's O's turn. So how we can do that is basically the easiest way to do that is to say is X turn and then set that equal to not state.value.isXturn. So this exclamation mark is going to just negate whatever it's in front of. So here, if we put it in front of our isXturn within our state value, that's going to hand me the opposite of isXturn. So now we have our modified button values, and then we have our isXturn. But there's still a problem here because the way that we have this code written right now, if X clicked that button and then O clicked it again, it would change to O. And we don't want to do that. We need that to stay as X the entire time. And to do that, what we're going to do is we're going to put all of this inside of an if statement. So if state.value.buttonValues at the ID that we want to modify, so at the ID that we passed into our set button function, if it equals our dash, which we were just using for our dash state, which we were just using for our blank state, if it's equal to our dash, then we're going to go ahead and run all of this code. If it's not equal to our dash, we don't want to do anything. So if I click that X, it's not changing it back to X's turn, and it's not writing anything on that button. For it to change back to X's turn, O has to click on a button that they're allowed to click on. So that should do all of that. But there's one more thing that we need to check here. For example, if I have this game right here, well, now X has won the game is over, O can't take a turn, right? When the game is over, the game is over. You can't keep playing. So I need to check if the game is over before we modify any button values. And the way that we can do that in here is just with another if statement. So if state.value.victor is equal to null, which is what we have it set to initially, then we're going to go ahead and set our button. And now our set button function is almost done. There's only one thing left, and that's basically before we, right now we have the state.value.victor set equal to null, which is our default. That's what it's going to come as when we reset our state or when we launch the app initially. But we need to modify that somewhere. So back in our view model, down here, what I'm going to do is I'm going to make a new function, private fun is game. We'll call this is game over. And this is going to return a Boolean value. And for now, I'm just going to say return false. Now up in this function, what we need to do is call that is game over function. And when we get there, what we're going to do is inside here, instead of just returning false, we're going to add all of the logic to see if our game is over. But before we do that, let's go ahead and build the UI and build our screen and see how that looks. So in our Tic-Tac-Toe screen, I'm going to make a new composable here. And this composable function, we're going to call fun Tic-Tac-Toe screen. And I'm going to pass in two parameters. One is going to be a modifier, which we're just going to set equal to the default modifier by default. And then after that, we're going to do view model, which is going to be of type Tic-Tac-Toe view model, which will be equal to a Tic-Tac-Toe view model by default. And then inside of this function, the first thing that we're going to do is we're going to say val state equals view model dot state dot value, and that will give us a reference to our tic-tac-toe state within our view model that we can then use inside of our screen. And if you look here, you could see we have, well, everything's arranged both horizontally across and vertically. So we have this message up top, and then we have all of our buttons down below. So let's go ahead and start with that message up top. The first thing that I'll need here, if we're going to stack data vertically, is a column. We're going to want this to fill up our entire screen. So we're going to say modifier equals modifier dot fill max size. And then after that, we're going to say vertical arrangement equals arrangement dot space evenly, and then horizontal arrangement, or sorry, horizontal alignment rather, is going to be equal to alignment dot center horizontally. And if you don't know what these mean, go see the previous video. We discussed it in detail in that video. And then after that, down here, we're going to need a few variables, and we're going to use those variables to populate whose turn it is, or in this case, who's going to win. So right in the beginning of the game, we see it is X's turn, and then O's turn, and then X's turn, and then O's turn, and then X's turn. And now that the game's over, it tells us who won. So we need variables to track all of that. So I'm going to have one variable here that we're going to call turn. So val turn equals if state.is X's turn, then we're going to say X's turn, and if it's not, we're going to say O's turn. So that's our first variable that we're going to have. Then we're going to say val turn message is going to be equal to tic-tac-toe \n for a new line. It is $turn. So that's going to give us, that'll give us this message, but it doesn't give us the message for the victor. So let's do that. Val winner equals state dot, this is going to be state dot victor, which is obviously null initially if you look in our state, but we are going to modify that in the additional logic that we add in the view model when we get to that. So that will be good later. So winner equals state dot victor, and then val winner message is going to be equal to Tic-Tac-Toe \n again for a new line, $ winner wins. Now, once we have all of that, we can come down beneath this and let's add a text to display that. Inside that text, we can say, well, we better import that first. And inside of that text, we can say text equals if winner does not equal null, because remember, initially we're setting that to null, our state.victor. So if winner does not equal to null, then we can say winner message, else turn message. So basically, if our winner is set to null, then we're going to display whose turn it is. And if we have a value for the winner, that means the game's over, so we're going to display who won there instead. Then after that, we're going to do text align equals text align.center, just to put that in the middle of our screen. And then we're going to say modifier is equal to modifier dot padding, and I'm just going to give that 16 dp just to space that out a little bit. For that modifier, let's add some font size to that. So font size equals 40.sp, because again, remember, we use SP for font sizes and DP for all other sizes, because SP is going to auto adjust for the different accessibility options that they have. So color equals material theme dot color scheme dot on surface, and then style is equal to material theme dot typography dot headline medium. Now, if you look at what we have versus what we need, right now we have a column. So this whole thing, of course, it looks like a column. And then we have a text inside of a column, which is this guy right here. Now, after that text, we have 3 buttons lined out horizontally, which means this is probably going to be a row. And in that row, we're going to need 3 buttons. And then after that, we need another row with 3 more buttons. And then finally, a third row with 3 more buttons. And then eventually, we need one last button down here. So we already have in our, if we look in our code, we already have a column here. So inside of this column, basically, we need to put 3 rows and then that final reset button. Let's add our row here. So row, and then inside the constructor for that row, I'm going to say horizontal arrangement equals, and this looks like arrangement space evenly. So we're going to do that. And then after that, we're going to say vertical alignment equals alignment.center vertically. And then finally, we need to tell it how big we want this row to be. So modifier equals modifier dot fill max width. And then finally, inside of here, we can actually put our buttons. So here we have our row. I can copy this 2 more times, and now we have 3 rows that are going to be arranged how we want them. And then inside of each of these, I need to put 3 buttons. And instead of just typing out the button composable here, which I could do, there's certain things of this button that we want to be able to control, and it's going to be very repetitive. So what I'm going to do is come down here and actually make a new function for building this button. I'm going to call it fun tic-tac-toe button, and we're going to take in a few parameters. The first one is going to be a string for the data that we're going to display on the button. And then we're going to have one called should change color. And this is going to be a Boolean. And that is simply there to track if we need to change the color. Like here, when the game is over and we have a victory, we need to highlight the 3 in a row. So that's what that Boolean is there to track. And then we're going to have an on-click function that we're going to pass in here. And it's just going to return a unit. That should be all that we need there. Now let's give a body to that tic-tac-toe button. And inside of this tic-tac-toe button, first of all, this is going to be a composable function. So we have to annotate that with composable. And then inside of here, we could say val color equals. And then if we should change the color, then we're going to say material theme without these brackets. We're going to say material theme dot color scheme dot tertiary, and then else we're going to say material theme dot color scheme dot primary. Now, after that, we're going to say button, and in here we're going to say on click is equal to the on click parameter that we passed in. Our colors are going to be equal to button defaults dot button colors, and then inside button colors we have to say we're going to define our container color, which is just going to be our color value that we defined up top, and then we need to tell it the content color as well. So content color equals, and here I'm just going to say color.white. We need to define what's going to go inside of our button. So inside of there, all I'm going to do is add a text field, and that text is going to be equal to button, and then we'll give that a font size of maybe 50 SP. That should be everything that we need for this tic-tac-toe button. So now if we come back up to our rows that we defined, we should be able in here just to simply declare all the buttons that we need. So tic-tac-toe, whoops, not a screen, tic-tac-toe button. Let's see, our button is going to be equal to, let me just back all of those out, and I'm going to say state dot button values at index 0, which again is going to be our first button in the top left corner. And then we're going to say state dot button winners, because we need to pass it whether that button needs to change. And then after that, I'm going to hand this a lambda, and instead of having that like that, I'm just going to put it on the same line. I'm going to say view model dot set button, and this is going to be 0. And the reason that I'm doing this on the same line is because it's just easier to copy this and paste it 3 times. And now, instead of 0, we can do 1, 2, same thing here, 1, 2, and then same thing here, 1, 2. And what I could do is I could copy all 3 of those, paste it in this row, and then paste it in this row. And now I can go 3, 4, 5, 3, 4, 5, 3, 4, 5, 6, 7, 8, 6, 7, 8, oops, 8, not 28, and then finally 6, 7, 8. So we should have everything that we need displayed on our screen at this point now. However, this is obviously hugely repetitive code. So all of these rows are the same, and then inside of that, we have 3 buttons each, and the only thing that's changing is the index that we're passing in. So I don't like this. If you're a beginner, you might be writing code like this, but I really don't like this repetitive code. So what I'm going to do is I'm going to come down here and make another composable function that we can use. And we're going to call this build row. And then inside this build row function, whoops, I need a font in front of that. So inside of this build row function, we're going to say row ID, type int, we're going to pass in the ID, we're going to say modifier, is going to be a modifier, which by default is going to be equal to a default modifier. And then finally, we're going to pass in the view model, which is of type tic-tac-toe view model, so that we have all the state data that we need. And now inside here, this is all going to look very similar. So I'm going to copy one of these rows, paste that down here. And the only difference you'll see is that we don't have this state.buttons anymore because we didn't pass in our state, but we did pass in our view model. So that's not really a problem. Now in here, all I need to do is I can say val, and basically we need to know which button we're building inside of this row. And I'm not passing in all the button IDs, I'm only passing in the row ID. So to do that, what I'm going to do is I'm going to make 3 variables, and I'm just going to call them first, second, and third. So I'll start with third. And the third one is going to be equal to my row ID that I pass in. So either 1, 2, or 3 times 3 minus 1. And hopefully this isn't too complicated, but I'll explain this here in a second. So my next one is going to be val second equals third minus 1. And then the third one is going to be val first equals second minus 1. So basically, if we look back at our values here, you've got button 0, button 1, and button 2 on the first row. So if I pass in a 1 for my row ID, I'm going to have 1 times 3 is 3, and then minus 1, which will give me 2. And then that minus 1 again will give me my second button ID of 1, and then again will give me my first button ID of 0. And this equation is going to work for any of these rows. So if I pass in a 3, well, 3 times 3 is 9, minus 1. Well, that gives me 8, and then minus 1 for the second gives me 7, and minus 1 again for the first gives me 1. So hopefully that helps make this a little more clear. Alternatively, you could just pass in 3 different IDs for the buttons that you want built within that row. But I'm doing it this way, just because I think fewer parameters is better. And then we're going to say val button colors is equal to our view model dot state dot value dot button winners, because that's the Boolean array that we're using to track our colors. And then val buttons equals view model dot state dot value dot button values. Now all we need to do is fix this down here. So instead of state dot button values, and let's actually just call this button values, we get rid of the state, and this is just going to be button value. This is just going to be button values instead of 6. We're going to say for this row, we're going to say first, and then same thing here. State button winners, we call that button colors, and instead of 6, this is going to be first, and then view model dot set view model, this is going to be first again. So same thing here, this is going to be second, this is going to be third, and then same thing here, get rid of all the states. We changed, this one's called button colors here, our local variable within the function that is, and then button colors, and then instead of 7 and 8, we're going to do second and third. And now, instead of all of this code up here, all of this code for the rows, I can go ahead and get rid of all of that. And all I need to do up here is I'm gonna say build row ID equals 1, view model equals view model. And copy that line 2 more times. Now row ID equals 2 and row ID equals 3. So this, to me, looks a lot cleaner in the code, and it's just as clear, if not more clear, as to what I'm doing with that. So I'm going to do it like that. And then finally, after that, I'm going to add one more button in here. And this is going to be for our reset. And this is going to be on click. We're going to say view model dot reset board. And then finally, we're going to say colors, or not finally, but we're going to say colors equals button defaults dot button colors. And we need to define the container color. And that's going to be equal to material theme dot color scheme dot primary. We'll use our primary color for that just so it matches all of our other buttons colors. And then our content color is going to be equal to color dot white. And now that button, the parameters are good. We need to actually say what we're going to put in the button. And that is just going to be a text field where our text is equal to reset game. And then our font size, we're going to set that equal to 32.sp. So now that should be everything that we need on our composable screen and layout. Let's go ahead and run that program. Oh, you know what? There's one actually pretty important part that we need still, and that's in our main activity. We need to come in here and we need to make a view model. View model, which is going to be equal to a tic-tac-toe view model. And then we need to call our tic-tac-toe screen and set our view model equal to our new view model that we just made. Now we can run that program. And there we go. We've got our tic-tac-toe board looks good. If we click on these, you see it's now working like we expect it to. But here, we're not quite done, you could see, because now we have X, X, X all in a row. This game should be over now, but it's not. And that's because I'm not checking that condition anywhere. Remember, I left that function in my view model is game over. I left that empty. Well, I returned false. So basically, we need to go back and populate that function with the logic that we need to calculate when the game is over. And you could see I could fill up the whole board and nothing happens. Let's just check our reset game button, and that does work. So all we need to do is populate this is game over logic inside of our view model. So in the view model, the first thing that we're going to need here is a way to, pretty much a way to compare 3 different buttons and see if their values match each other. So I'm going to make a private function and we're going to call this compare spaces, as in game spaces. And I'm just going to pass it 3 integers. So first is an integer, second is going to be another integer, and then third is going to be our third integer. And this is going to return a Boolean, which is going to be set to true if everything matches. And this first, second, and third, these integers, if you look back at this phone, that's going to refer to our button index. So remember the top row is 0, 1, and 2, 3, 4, and 5, and then 6, 7, and 8 on the third row. So in here, what we need to do, first, we need to check if they're not all set to X or O, then it doesn't matter. We don't need to do any comparison at all because the game's not over from these 3 being compared. So we can say return if state.value.button values, if button values first is equal to just an empty dash, then I'm going to go ahead and return false. So you'll notice here I'm only actually checking the first one, and that's because on this tic-tac-toe board, if the first one is X, well, now this X is not going to be equal to a dash and a dash. Likewise, if it was O, right, this O can't be equal to a dash and a dash. So you could check if every single one of these buttons was populated with an X or an O, but because we're going to be checking if they're equal to each other anyway, really all we need to do is check if one of them is equal to a dash. So if the first one is not a dash, then our function is going to work fine. So down here, we could say else if, and then inside of here, we need to define our logic for if all of these match. And then finally, inside of this if statement down here, all I'm going to do is I'm going to make a new array of colors. So we're going to say val button winners equals underscore state dot value dot button winners dot copy of, and then we're going to say button winners of the first is going to be equal to true. And then I can just copy that line 2 more times. Set for second and then third equal to true. And what this is going to be doing is if in this if statement, which we haven't defined yet, but basically this is going to tell us if our 3 buttons match. So if they match, I'm going to set all of these to true in my button winners array, and that's going to tell my screen to change the color. And then after that, all we have to do down here is update our state. So state.value equals underscore state.value.copy, where button winners is going to be equal to our new button winners array that we just modified. And then in here, we can return a true. And then finally, we'll add an else for a catch-all for if they don't match. And this is just going to pass back a false to them. Okay, now up in here, what do we need to check? Well, basically, if I have a row here, I need to check if this first one, which is X, matches the value of the second one, which is O, and then also if that matches the value of the third one, which is also O. So I'm going to actually need 2 if statements in here, or 2 conditions that both need to be true. So I can say if state.value.button values at the location of first equals state.value.button values at the position of second. And then after that, we could say and underscore state.value.button values at the position of second is equal again to state.value.button values at the position of third. So this is going to be doing if first is equal to second and second is equal to third, then this is going to evaluate to true, which will run all of this code and update our state with the updated colors, and will tell the game that it's over. Actually, to do this, I'm just going to make this a little bit easier to read. So we're going to cut that out. We're going to make a new value up here, say val first to match, and that's going to be equal to that. And then I'm going to say val second to match, which is going to be equal to the other side of our if condition down there. And then finally, I'm going to say val all rematch is going to be equal to first to match ANDed with second to match. And in here, instead of all of that, all we need to do is say else if all rematch. So this obviously does the same exact thing with that code up there. It's just a little bit easier to read this part in English now because else if all 3 match, then we know to run this code, rather than having to look at state.value.button first equals state.value.button values second, anded with this, and that's just a lot to read. This is a lot simpler to read, especially if we had to go back and maintain this code. So I like to put my Boolean values that I'm using in if statements, especially if they're complicated like that. I like to put them in a variable with an English name that very clearly says what that's doing. So now that we have this function, you can see we're actually only comparing 3 buttons here, and it doesn't necessarily specify which 3, but in Tic-Tac-Toe, you can win either by getting 3 in a row, 3 in a column, or 3 diagonally, like we have here, XXX, that's all diagonal. So in here, my view model again, I'm going to add a few new functions. The first one is going to be private fun row as winner, and I'll take a row ID here, which is going to be of type int, either 1, 2, or 3. This is going to return a Boolean, a true or false, for if a given row has a winner in it. And again, just like we did in our screen, where we use this logic here to calculate the row, to calculate the indexes on the row, I'm going to do that within here as well. So we're going to have our first, second, and third. And then finally, all we need to do is say return compare spaces first, second, third. So that is now going to tell us if our row, if any row has a winner. So I can pass it a 1, a 2, or a 3. Really, we should put an error checker up here to verify that I don't pass it like a 4 or a 5 or a 6, because we don't have that many rows in Tic-Tac-Toe. But since this is just a private function and I'm only using it inside this view model for demo purposes, I'm not going to worry about that right now. So that's how we have, that's how we can check if a row has a winner. Now we can say private fun column has winner. And we can say, we'll pass in a column ID here, which is going to be of type int, which again can really only be 1, 2, or 3. Boolean, we're gonna pass back a Boolean from that function. And then in here, it's going to be the same concept as above. We're going to say val first equals column ID -1, and then val second equals first plus 3, and val third equals first plus 6. And then after that, we're just simply going to copy that return spaces line and paste it. So we return our compare spaces with our first, our second, and our third. And these numbers here, let me just remind you, if we look at our indexes here, so this is our first column, this is our second column, and then this is our third column. So the first ones are going to be 0, 1, and 2. So if I pass in a 1 for the first column, I need to subtract 1 off of that because we're starting our array at 0. For the second column, if I pass in a 2, I need to subtract 1 again. And then same thing there, if I pass in a 3, I need to subtract 1. And then to get to the button in the row beneath that, all I need to do is add 3, right? So 2 plus 3 is 5, plus 3 is 8. 1 plus 3 is 4, plus 3 is 7, and so on. So that's where these numbers are coming from. But now we have our rows and our columns accounted for, but we need a function down here as well to check our diagonals. And I don't really have a neat mathematical way to do that. Maybe there is one if I sat down and thought about this a little more, but I'm not going to. All I'm going to do is I'm going to say diagonal has winner, Boolean, and basically we're going to have a function for our first diagonal, and in here I'm going to return compare spaces, and all I'm going to do is do 0, 4, 8, and then the same thing down here, copy that, paste. We're going to call this second diagonal has winner, and this is going to now be 2, and 4, I guess, is the same, and then 6. And again, those numbers are coming from here, 0, 4, 8, and then 2, 4, 6. So now that I have all of these functions to check if I have row winners, if I have column winners, if I have either of the diagonal winners, I can finally come back up to my isGameOver function, and we can define that. So instead of just returning false, let's do, well, actually, we'll leave that part because that can be our catch-all at the end. Whoops. So up here, all I'm going to do is say if row has winner 1 or row has winner 2 or row has winner 3, then we need to return true. Else, if column has winner 1 or column has winner 2 or column has winner 3, then we need to do the same thing and return true. And then we can say else if first diagonal has winner or second diagonal has winner, then we can again return true, and finally leave this one down here for the catch-all, for the return false, for when the game is not over. Now, because we're calling this function already from our set button function at the end of it in our view model, which is already tied to these buttons on their onClick attribute, if I go ahead and run this application again, you can see now that once I get 3 in a row, it updates all of my X's, and it has set the color, but it didn't change my message. It still let it be O's turn. So there's one more thing that we need to go fix. So let's go do that. So go down back to the compare spaces, and actually in here I left something pretty important out. So we need to say if all 3 match, then we need to actually update our state here. So state dot value equals, because you remember on this set button function, we're checking if our state dot value dot victor is equal to null, and if it's not, or if it is equal to null, then we run all this, and that's why it's still letting us click over here on our game board, because we forgot to update this victor value. So down here, we're going to say state.value equals state.value.copy, and then inside of here, we're going to say victor is equal to state.value dot button values at the first index. And really at this point, if they all match, it doesn't matter if you use first or second or third, but I'm just going to use first. Now run that program again, and you can see we've got XXO, so it works diagonally. Reset the game, and it works in our column, and let's try it in a row as well. Maybe let's let O win this time, and we can see it works there as well, and it's updating the message. So that's really all that you have to do to build this super simple yet functional tic-tac-toe game that we have just constructed in this video. Hopefully this wasn't too difficult for you and you were able to follow relatively simply. If this has been helpful for you, and if this series is being helpful and benefiting you, please like and then subscribe to our channel, and definitely continue to follow along as we're continuing to put out videos that have to do with more and more of the different pieces of the Jetpack Compose. And we will see you in the next video.